In order to vibration test your sample or device, we require a source of vibratory energy. Vibration labs use two principal types of machines to provide this energy: electrodynamic or electrohydraulic shakers. Each type of shaker has its advantages. Electrodynamic shakers are capable of a wide frequency range from 5 Hz to 3,500 Hz and displacements up to 75 millimeters. Electrohydraulic shakers are typically more rugged than electrodynamic shakers and are capable of larger displacements, but are generally limited to frequencies below 200 Hz. We use electrodynamic shakers at Paragon Systems Testing to perform vibration testing in 3 axes. An electrodynamic shaker consists of 4 basic components: an amplifier, an actuator, a controller, and a slip table. The shaker amplifier works very much like a stereo system audio amplifier. It uses a mains electrical energy and takes a low-level alternating electrical signal from a vibration controller and amplifies it into a signal of many thousands of watts. If we continue with the stereo system analogy, an electrodynamic actuator is similar to an audio speaker. In a stereo system speaker, the amplifier alternating electrical output is applied to a coil of wire suspended in a circular gap surrounded by a permanent magnet. The coil in the speaker is forced to move back and forth due to magnetic induction. The coil is attached to the speaker cone, which makes sound by moving the air in front of the speaker cone. In a vibration system actuator, the amplifier output is also applied to a coil. Except for very small shakers, this coil will be surrounded by an electromagnet instead of a permanent magnet. The coil in an actuator is forced to move back and forth by the same principle as in an audio speaker. In the case of a shaker, the coil is attached to a mounting surface for vertical or Z-axis testing and is called the armature. The armature and its attached coil, the electromagnet, and the surrounding support structures are called the actuator and are visible here in a partially disassembled actuator. The amplifier input in an audio system can come from a radio receiver or a digital media player. Your ear senses the level of sound produced by the speaker, and you control the level of that sound by varying the volume control on the audio amplifier. In a shaker, we control the actuator output levels a little differently. The shaker amplifier input is provided by a vibration controller, which is programmed to produce specific acceleration, displacement, and frequency test profiles, which match the vibration test method. An accelerometer sensor mounted to the armature measures its movements. The controller senses this accelerometer signal and adjusts the amplifier input so that the armature movement corresponds with the vibration test profile programmed into the controller. The actuator by itself can only produce vibration in one direction, typically in the vertical or Z-axis. Vibration tests usually require vibration to be applied to a test article sequentially in 3 mutually perpendicular directions: X, Y, and Z. In a shaker, this is typically accomplished by rotating the vertically aligned actuator 90 degrees to a horizontal position after completion of the Z-axis test. The now horizontal armature is then attached to a horizontal sliding surface. This sliding surface is called the slip table. The slip table surface is where test articles are attached when performing X and Y axis tests. You can learn more about the individual components of an electrodynamic vibration shaker by following the links below.